You know, I was thinking the other night about my father. In the last years of his life, he used to turn the television up so loud that you could hear it from the street. And he'd smell his food before he ate it, not out of suspicion, just habit. Like he was trying to find something that used to be there. And I didn't think much of it at the time, but later, much later, I started to wonder about what was actually happening inside him. What was changing? Not in his personality, not in his mind, in the actual physical instruments he used to experience the world. Because that's what your senses are. They are instruments. Extraordinarily precise, extraordinarily complex, physical instruments that your body uses to sample reality. And like all instruments, they drift, they degrade, they lose resolution. By age 60, the average person has lost roughly a third of their taste receptors. By 70, the lens of the eye has lost nearly all of its ability to change focus. By 80, the inner ear may be processing only half the sound frequencies it could in youth. And most people experience this as just getting old. But I want to show you something different. I want to show you the actual physics of what's happening, the mechanism, the reason. Because when you understand why your senses change, not just that they do, you start to see something genuinely extraordinary about the nature of perception itself. And I think by the end of this, you'll experience the world around you just slightly differently than you did before. Understanding how your senses change as you age could change how you think about experience itself. Think about what your senses actually are. They are not passive receivers. They are not windows that the world shines through. They are active translators. Every sense converts one form of physical reality, electromagnetic radiation, mechanical vibration, chemical concentration, into the electrochemical language your brain can read. You do not see light. Your eyes absorb photons, and your visual cortex constructs an image. You do not hear sound. Your ears convert pressure waves into nerve signals, and your auditory cortex builds an experience of sound. You do not taste food. Your taste receptors detect specific molecular shapes, and your brain assembles them into what you experience as flavor. This distinction matters enormously, because it means that when your senses change with age, it's not just that the world gets quieter or blurrier or flatter. It means the translation is changing. The instrument is drifting from calibration, and the version of reality your brain is constructing is shifting away from what it once was. Which raises a question that I find deeply unsettling. If your senses have always been constructing your reality rather than simply receiving it, if the world you experience has always been a translation, then what does it mean when the translator changes? Is the world getting dimmer? Or is your instrument for measuring brightness changing? Is food getting blander? Or is your chemical detector losing sensitivity? These questions have real answers, physical answers, and they connect directly to some of the most fascinating things Feynman ever thought about the relationship between the observer and the observed. Let me take each sense in turn, and let me show you not just what changes, but why, at the level of molecules, cells, and physics. Now, realizing that the first two senses to show significant age-related change are the ones that operate at the speed of light and the speed of sound, this is where the physics becomes interesting. Let's start with vision. Here's the analogy. Imagine a camera lens made not of glass, but of living tissue, a transparent protein structure that can change shape, thickening to focus on something close, flattening to focus on something far. That's your lens, and it's remarkable. When you're young, it can shift focus in milliseconds. It's flexible, clear, and responsive. Now imagine that over decades, new layers of protein are added to this lens from the outside in, like rings on a tree, but the old layers in the center can never be replaced. They simply accumulate, they compress, they harden. By your mid-40s, The center of your lens is made of proteins that have never been replaced since you were born. They are, in a literal sense, as old as you are, and hardened protein cannot flex, cannot change shape, cannot shift focus. This is presbyopia, the near universal loss of close focusing ability that hits almost everyone in middle age. It is not a disease, it is not a failure. It is simply what happens when a biological optical system runs out of new material to replace its core. But that's only one part of how vision changes. The other part is even more interesting. The cells in your retina that detect color, your cone cells, require enormous amounts of metabolic energy. They are among the most energy-hungry cells in your body. As blood supply to the retina gradually reduces with age, these cells receive less fuel, and like any instrument running on reduced power, they lose sensitivity. Colors become slightly less saturated. Contrast reduces. The fine detail of the visual world, the crispness of edges, the subtlety of shadows, softens. What you are experiencing is not the world becoming less vivid. It is your instrument for measuring vividness running on lower power. Now, hearing. Here's the analogy. Imagine a row of tuning forks, each one calibrated to a different frequency, from the deepest bass to the highest treble. And imagine that these tuning forks are made of tiny hair cells, microscopic structures lining the cochlea of your inner ear. When sound waves enter your ear, these hair cells vibrate in response to their matching frequency. Each one fires a nerve signal, and your brain assembles the full spectrum into what you experience as sound. Now here is the critical fact. These hair cells cannot regenerate. In almost all mammals, including humans, once a cochlear hair cell is damaged or dies, it is gone permanently. There is no replacement. And they are exquisitely fragile. Loud noise damages them, but so does time. Simply the accumulated metabolic stress of decades of normal use causes them to fail. The high-frequency cells fail first, which is why the first thing most people lose is the ability to hear very high pitches, the top strings of a violin, the consonants in speech, the S and F and TH sounds that carry so much of the meaning in language. And once those cells are gone, the tuning fork is simply missing from the row. That frequency no longer exists in your experienced world. Not quieter, absent. Realizing that the three remaining senses, smell, taste, and touch, change through completely different mechanisms than vision and hearing. This is where the picture becomes genuinely fascinating. Let's talk about smell first, because smell is the strangest sense of all. Here's the analogy. Imagine a lock and key system. Thousands of different locks, your olfactory receptors sitting at the top of your nasal cavity, and the keys are odor molecules floating in the air. When a molecule with the right shape drifts into your nose and fits into a matching receptor, that receptor fires. Your brain receives the signal, compares it to a vast library of remembered molecular shapes, and produces what you experience as a smell. Now, unlike the hair cells of your inner ear, your olfactory receptors can regenerate. They replace themselves roughly every 30 to 60 days throughout your life. So why does smell decline with age? The answer is that the regeneration slows. The stem cells that produce new olfactory receptors become less productive, and the regenerated receptors, when they do form, are slightly less precise than the originals. It's like a photocopier that has been used 10,000 times. The copies are still recognizable, but the fine detail is degraded. The subtle distinctions between similar smells, the difference between a Cabernet and a Merlot, the difference between your grandmother's kitchen and someone else's, those distinctions blur. There is also a structural issue. The olfactory nerve, the pathway that carries smell signals to the brain, passes through tiny holes in a bone at the base of the skull. Over decades, these holes narrow slightly. The nerve fibers are compressed. Fewer signals get through. The world doesn't become odorless. It becomes less specific, less textured. The library of scent that once contained thousands of distinct volumes now has gaps. Pages are missing. And taste, which most people think of as independent, is actually between 50 and 80% dependent on smell. What you experience as flavor is primarily retronasal olfaction, odor molecules from food traveling up the back of your throat to your olfactory receptors as you chew and swallow. When smell degrades, flavor degrades with it. This is why food tastes different as you age. Not primarily because your taste buds have changed, though they have, but because the smell component that was doing most of the work has faded. Your taste buds do change too. You're born with roughly 10,000 of them. By age 70 or 80, you may have half that number. The ones that remain have blunted sensitivity, particularly to saltiness and sweetness. Which is why older people often add more salt and sugar to food. Not because their preferences changed, but because their instrument for detecting salt and sugar has become less sensitive. And finally, touch. Here's the analogy. Imagine a sheet of paper covered in millions of tiny pressure sensors, each one connected to a wire that runs to a central processor. Different sensors detect different things: light touch, deep pressure, vibration, temperature, pain. That's your skin, and it is astonishingly sophisticated. With age, the density of these sensors decreases. The fingertips, where they are most concentrated, lose roughly 40% of their Meissner's corpuscles, the receptors responsible for fine touch discrimination, by age 70. This is why threading a needle becomes harder, why the texture of fabric that used to feel distinct begins to feel uniform, why a gentle touch that once felt warm and specific begins to feel less precise. The world doesn't become less touchable. The instrument for measuring touch loses resolution. Now let me pull back, because across all 5 senses, there is a deeper pattern. And I think it's one of the most important things I want to show you today. Here's what each sense has in common. Every sensory system in your body is a transducer, a device that converts one form of energy into another. Your eye converts photons into electrochemical signals. Your ear converts pressure waves. Your nose converts molecular shapes. Your tongue converts chemical concentrations. Your skin converts mechanical force and temperature. And in every case, every single one, the transducer degrades with time. Not randomly, not chaotically, in ways that are deeply predictable, deeply physical, and deeply connected to the second law of thermodynamics. Entropy, the tendency of ordered systems to become disordered, operates on biological transducers the same way it operates on everything else. Here's the analogy. Imagine a very precise scientific instrument, a spectrometer, say, that can detect the difference between wavelengths of light separated by fractions of a nanometer. When it's new, it's calibrated perfectly. Every reading is accurate. Every distinction is sharp. But use it for 50 years. Use it in a room where the temperature fluctuates, where vibrations from the street subtly shake its components, where the optics collect the thinnest possible film of dust. Use it simply by existing in a world governed by entropy. The instrument doesn't break. It drifts. Each reading is still meaningful, but the resolution is lower. The distinctions it can make are fewer. The world it can describe is slightly coarser than the one it could describe when new. Your sensory systems are biological instruments, and they drift in exactly this way. The lens hardens and loses focal range. The hair cells accumulate damage and fail. The olfactory stem cells slow their regeneration. The taste buds reduce in number. The mechanoreceptors in skin thin out. In each case, the instrument loses resolution. The world it can describe becomes coarser. But here is what I find remarkable, and what Feynman would have found remarkable too. Even at the resolution of an 80-year-old sensory system, the universe is still incomprehensibly rich. The instrument has degraded, the reality it's sampling has not. I want to stop here for a moment, because something just occurred to me that I think is worth sitting with before we go further. We've established that your senses are instruments, that they degrade with age, that the world you experience is a translation, and that the translator changes over time. Which means that the version of the world your parents experienced in their final years was genuinely different from the version you experience now. Not metaphorically, physically. The actual signal reaching their brain was lower resolution, less specific, more compressed. And the version of the world you will experience in your own final decades will be different from the one you experience today. I don't say that to be grim. I say it because I think there's something important in taking it seriously. Realizing that you are right now, today, at whatever age you are, experiencing a version of reality that you will never experience again at quite this resolution. Does that change how you want to use your senses today? Tell me in the comments. I mean that sincerely. This is one of those questions I don't think has a right answer, but I think the act of asking it is worthwhile. Now, understanding what Feynman actually believed about the relationship between the observer and physical reality, this is the part I've been building toward. Feynman spent decades thinking about measurement, about what it means to observe something, about the relationship between the physical instrument doing the measuring and the physical reality being measured. And he came to a view that I think applies to your senses in a profound way. The view is this: there is no such thing as an observation that does not involve an instrument, and there is no instrument that does not have a resolution limit. Even in physics, even with our most sophisticated equipment, what we measure is always a function of both the physical reality out there and the physical properties of the instrument we're using to probe it. Heisenberg's uncertainty principle, in one sense, is precisely this. The act of measuring at the quantum scale inevitably disturbs what you're measuring. Observer and observed cannot be fully separated. Now, I am not saying your aging retina is governed by quantum mechanics. What I am saying is something more subtle. Something that Feynman understood in a deep way. Your perception of reality has never been reality itself. It has always been a model, a construction, a translation produced by your sensory instruments. And this has been true since the moment you were born. When you were young and your senses were at peak sensitivity, you were not experiencing reality directly. You were experiencing a very high-resolution translation of reality, the finest translation your biology could produce. As you age, that translation becomes coarser, but it does not become false. It does not become meaningless. It does not become less real. It simply has a lower sample rate. Think about music recorded at different bit rates. At the highest resolution, you hear every overtone, every subtle resonance in the room, every breath the musician takes. At a lower resolution, you still hear music, beautiful music, moving music. It is simply less detailed. The composition hasn't changed. The universe hasn't changed. The instrument receiving it has. And here is what I find most striking about all of this. Feynman, in the last years of his life, when he knew he was dying, he said something that I have thought about ever since. He said that he found the world, even at the end, to be completely and inexhaustibly interesting. Not despite his diminished senses, not in spite of what aging had taken. He said that reality, even filtered through an aging and imperfect instrument, was still so astonishingly strange and complex and beautiful that he could not imagine running out of things to wonder at. The resolution had dropped, the wonder had not. Now, realizing that the brain doesn't simply accept degraded sensory input, that it actively compensates in ways that are genuinely remarkable. This changes the picture significantly. Because here is something that most people don't know. The brain is not a passive receiver of sensory data. It is a prediction machine. It constantly generates models of what it expects to perceive and uses incoming sensory data to confirm or correct those models. This means that as sensory input degrades, the brain leans more heavily on its models. It fills in the gaps. It makes educated inferences based on context, experience, and expectation. Here's the analogy. Imagine receiving a letter where some of the words have been blurred in transit. If you know the language well, if you've read thousands of letters and know how sentences work, you can reconstruct the missing words from context. A person who has just learned the language would be lost, but an expert reader barely notices the blur. Your aging brain is that expert reader, and the letter is the sensory signal. This is why experienced musicians can hear things in a piece of music that younger listeners miss, even if the musician's raw hearing has declined. Their mental model of the music is so rich that it enhances the degraded signal. This is why experienced wine tasters can identify vintages that their objective taste sensitivity can no longer fully distinguish, because their cognitive model of flavor fills in what the dulled receptors miss. This is one of the most important and underappreciated facts about aging perception. The instrument degrades, the interpreter improves. And in many domains, perhaps most of the ones that matter, the improving interpreter more than compensates for the degrading instrument. What you lose in raw resolution, you partly recover in contextual depth, in the richness of your model, in the accumulated library of experience that you bring to each new perception. A world experienced by an 80-year-old with a lifetime of sensory memory is not the same as a world experienced by a 20-year-old with fresh sensors. Both are extraordinary. Both are real. Both are complete in their own way. So, what do you actually do with all of this? Let me summarize what we now know, and then give you something concrete to take with you. Your 5 senses are biological transducers. Each one converts a different form of physical reality into signals your brain can read. And each one degrades with age through specific, well-understood physical mechanisms. Vision loses focal flexibility and contrast sensitivity as the lens hardens and retinal blood supply reduces. Hearing loses high-frequency range as irreplaceable cochlear hair cells fail. Smell loses specificity as olfactory stem cell regeneration slows. Taste loses intensity as it follows smell's decline and taste bud numbers reduce. Touch loses resolution as mechanoreceptors in skin thin out. In every case, the instrument drifts. The resolution drops. The world it can describe becomes coarser. And yet, the brain compensates. It fills in gaps with prediction. It enriches degraded signals with contextual depth. The interpreter improves even as the instrument fades. Now, what do? First, protect what you can protect. Hearing loss from noise exposure is almost entirely preventable. Wearing ear protection at concerts, on construction sites, with earphones at high volume, these choices preserve cochlear hair cells that cannot be replaced. This is not about being cautious. It is about keeping more of your tuning forks in the row. Second, use your senses deliberately. As sensory resolution declines, attention becomes more important, not less. The person who eats while looking at their phone and the person who gives their full attention to the same meal are not having the same sensory experience. Your brain can only enhance and interpret what it actually receives. Give it something to work with. Third, build the interpreter. The richness of your sensory experience in later life depends enormously on how rich your sensory models are now. Learn music. Develop your palate. Pay attention to the quality of light, the texture of surfaces, the specific smell of different environments. You are building the library your brain will use to fill in the gaps later. And fourth, and this one is Feynman's lesson above all others. Do not confuse lower resolution with lesser reality. The universe is not less interesting because your instruments for probing it have changed. It is, if anything, more interesting because now you understand something that you didn't when your sensors were fresh. You understand that perception has always been a translation, that the world you experience has always been a model, that you have never, not once, not even as a child with perfect senses, experienced reality directly. You have always been doing exactly what you will do at 90, constructing the best possible version of the world from imperfect instruments. The instruments change. The act of construction never stops. Let me leave you with something I can't stop thinking about. Right now, in this moment, you are experiencing the world through instruments that will never again be exactly as they are today. The photons entering your eyes, the pressure waves reaching your ears, the molecules drifting across your olfactory receptors. Your brain is taking all of it, all of that physical information, and constructing something, an experience, a moment, what you call reality. And this has always been happening. Every moment of your life, every sense you have ever had has been translating physical reality into experience. You have never touched the universe directly. You have only ever touched your brain's best model of it. Feynman found this thrilling rather than frightening. He thought the fact that we could learn anything about physical reality, given how indirect our access to it is, was one of the most astonishing things about the universe. That despite the limitations of our instruments, despite the fact that every sense is a translation and every perception is a construction, the universe has left enough information in the signal that we can figure it out. So here is what I want you to sit with. You are a physical instrument trying to understand a physical universe, using other physical instruments, your senses, that are themselves subject to the laws of that universe. And somehow, it works. Doesn't that strike you as extraordinary? Tell me in the comments. I genuinely want to know.